Another misconception is that a science teacher's job is to just teach those facts. There is so much more to science as found in the nature of science. The nature of science is a way of knowing. It is how science functions. Here you will see an example of a real scientist and how she incorporates two aspects of the nature of science: observability and tentativeness. You will see that science is actually a way of thinking and of understanding. Most scientific knowledge is durable, but also is subject to change based on new evidence, as our scientists will show you.
Kathy Scanlon. I'm a geologist with the U.S. Geological Survey in Woods Hole, Massachusetts. As a marine geologist, I study the seafloor and I look at the materials such as the rocks and sediments that make up the seafloor, and I also look at the processes that form the shape of the seafloor, the natural processes. And a lot of what I do would be called exploration, because there are vast areas of the seafloor that are really not well known. And I also do a lot of mapping of the seafloor. To do that mapping, I use a variety of sonar instruments to make images of the seafloor using sound instead of light. I think that my work demonstrates the scientific identification criteria of observability and tentativeness very well. In 2008, I participated in a research cruise to the Drake Passage. That's the area between the southern tip of South America and Antarctica. One of our goals on this trip was to make a map of a mountain there called Sars Seamount. In the figure on the left, you can see a map that shows what we knew about the shape of Sars Seamount before our expedition. Very simple contours. On the right screen, the white line shows where our ship went. Sars Seamount is right here, labeled number 5. And now I'm going to show you the map that we made. Here you can see the old contour lines, these smooth white contours, the same ones that you see in the image on the left. The new contour lines are these gray ones with the colorized topography showing. And you can see that the gray lines are much more detailed than the older contour lines. So, is one of these maps wrong? No, it's not wrong. It's just a case of us observing the same feature using better and higher resolution instruments. The first map only told us that there was a seamount there, whereas the second map, the newer map, shows that the seamount has a flat top. You can see right here, a flat top, and it has ridges and bumps on the sides. Someday, someone else will go back there. Another scientist will return to the Drake Passage and map Sars Seamount, and using even better instruments, and make a more detailed map. So what will that map show? We don't really know. Will it change our understanding of how the seamount formed? Maybe, but that's okay. These maps are examples of observability in science. They also demonstrate the tentativeness of science and why we always have to be willing to revise scientific theories when new, better data become available.